This is video lesson number 5 in our optics series, looking at total internal reflection. Now that you've seen an example of total internal reflection, we're going to talk about what conditions need to be met in order for that to occur. So total internal reflection only occurs when all of the light is reflected back within the medium. So this is how light works in fiber optic cables. The light shines through and is able to pass because it's just reflected back within the medium. It doesn't escape into the air or out of the particular glass or plastic. Okay, now this can only happen if certain conditions are met. Okay, so for the first one, okay, it only happens if light is going from a more optically dense medium into a less optically dense medium. So the light has to be within like glass or plastic or something that's more dense than whatever it's beside, so the air. So light passes from a more optically dense medium into a less optically dense medium. Okay, so where it's starting out, the optical density, so N1, okay, that's the N of the medium that the incident ray is in, has to be greater than the optical density, so the N of the second medium that it would pass through to if total internal reflection isn't happening. Okay, the second condition required for this to occur is that the angle of incidence, okay, has to be greater than the critical angle. So that means that your theta I, so your angle of incidence, has to be greater than theta C, which is your critical angle. Now your critical angle is a specific angle, so it could be, 54 degrees or something like that, but the critical angle is the angle of incidence that results in an angle of refraction of 90 degrees. So when something's traveling from a more optically dense medium into a less optically dense medium, the light is speeding up, which means that if you think about the diagrams that you drew in the last video, your angle of refraction becomes greater and greater than your angle of incidence. So eventually you're going to reach an angle of incidence where the angle of refraction is going to be in line with the surface. So that's that 90-degree angle there, and that's your critical angle. So let's go through these examples at the bottom here. So our first example is when the angle of incidence is less than the critical angle. So here our angle of incidence, and here is our angle of refraction. So you'll see, because we're going from more dense to less dense, this block is representing, glass or plastic or something like that. So this is your N1 going to your N2, where N1 is greater than N2. And so your angle of refraction is greater than your angle of incidence because the light is speeding up as it comes in. So in this case, we have refraction occurring, Okay, and the light bends away from the normal as it speeds up. So light bends away from normal. In case number 2, okay, we still have N1 greater than N2. So we're coming from a more optically dense medium into a less. Our angle of incidence is a little bit bigger this time, and it's resulting in, as we move this angle of incidence out, okay, our angle of refraction is becoming greater, and once it becomes up to 90 degrees here, we're having our angle of, or our refracted ray being in line with the surface of the glass. So it's perpendicular to the normal. So when theta I equals the critical angle, light bends exactly 90 degrees. If you continue to increase the angle of incidence out even more, so here we can see it's getting even bigger, what's going to happen is total internal reflection. So all of the light, rather than passing through and being transmitted, is going to be reflected back within the substance, so the glass or whatever. So this is when you get total internal reflection. So let's just break those words apart, because really it's telling you exactly what it is. But sometimes people don't make that connection. So total means all of the light. Internal means that it's not being transmitted, it's staying within the same medium that it started in. And then reflection, remember, is when light bounces off something, it's not passing through to the back side. So total internal reflection, all of the light is staying within the medium and being reflected back out, where your angle of reflection is equal to your angle of incidence. So following the laws of reflection. So over the next couple of pages, so page 24, 25, and 26, you've got some practice questions, kind of like a little quiz to work on what we've been talking about over the last couple of questions or lessons on refraction. Complete those 3 pages, take some pictures, and send it in for homework.